Welcome to the Range and Interquartile Range module of Elementary Statistics. In this section, you will learn the definition of variability, how to calculate range, and how to calculate quartiles and the interquartile range. Variability is the study of how the values in a dataset are distributed relative to the center. It complements measures of central tendency, such as the mean and the median, because it shows how data is distributed around those central tendency values. The simplest measure of variability is the range. It is the difference between the largest and smallest value in a set of values. There are pros and cons to the range. On the positive side, it is easy to calculate a simple subtraction, and it's easy to understand the difference between the extremes using the range. On the other hand, because it only looks at the extreme values, it does not weigh the values in between. It doesn't show whether the center data is clustered close to the mean or far apart. As a result, it is also susceptible to outliers. Consider the following data set. Remember that the range is the difference between the largest and smallest value in this set of values. In this case, the largest value is 9. The smallest value is 1. The range is the largest minus the smallest value, or 9 minus 1, which is equal to 8. In this case, the range gives a good sense of the data set. The data values are clustered below 10, close to the mean. Consider this data set now. Remember that the range is the difference between the largest and smallest value in this set. In this case, the largest value is equal to 1,000. The smallest value is equal to 2. The range is thus equal to 1,000 minus 2, or 998. Notice how in this case the range does not give a good sense of the data set because of the value of 1,000, which is an outlier. Most of the data is clustered under 10, but you can't determine that from the range. From this range, you would expect a much more variable data set full of larger values. Quartiles and the interquartile range are another way of looking at variability. Quartiles are percentiles. Percentiles are used to describe the distribution of data. A percentile is the value of a variable below which a certain percent of observations fall. You're most familiar with percentiles from standardized test score reports. When you received a standardized test score report and found that you got, for example, an 85th percentile score, this means that 85% of other test takers scored lower than you. Quartiles are the most commonly considered percentiles. Quartiles divide a data set into 4 equal parts, the first through 4th quartiles. The first quartile, Q1, is the 25th percentile of the data set, or the median of the first half of the data set. The third quartile, Q3, is the 75th percentile of the data set, or the median of the second half of the data set. The interquartile range, also known as the IQR, is the difference between the first and the third quartiles. It has positive and negative attributes. On the positive side, the IQR accounts for the middle values of the data set, and it's not susceptible to outliers. However, it takes a long time to calculate because it requires calculating 2 medians, that of the first and second halves of the data set, and it does not account for extreme values. You don't know the full gamut of the data set from the IQR. Remember that the interquartile range, IQR, is the difference between the value of the third quartile and the first quartile. This can be represented as an equation, IQR equal to Q3 minus Q1. Consider the following data set. To calculate the IQR, the first step is to order the data set from smallest to largest. This is shown in the second table. Next, calculate the medians of both halves of the data set. In this case, there are 8 values in the data set. This means that there are 4 values in the first half and 4 values in the second half. The median of a data set with an even number of values is equal to the average of the 2 center values of the data set. So, Q1, the median of the first half of the data, is equal to the average of 2 and 3, or 2.5. Q3, the third quartile and the median of the second half of the data, is equal to 7 plus 8 divided by 2, the average of 7 and 8, or 7.5. To To calculate the IQR, take the difference between Q3 and Q1. Q3 is equal to 7.5. Q1 is equal to 2.5. Therefore, the IQR is equal to 5. Consider the following range and IQR challenge question. Below is a cumulative frequency chart showing the distribution of exam scores out of a possible score of 5 for statistics class. Calculate the range and IQR from this data. First, let's understand how the cumulative frequency chart works. In the left-hand column is a list of the possible scores in the exam. 0, 1, 2, 3, 4, and 5. On the right-hand side is the corresponding number of total students who have a value equal to or less than each score. For a score of 0, there are 10 total students who have a value of 0. There is no value less than 0. For a score of 1, 22 students have a value of 1 or 0. Since we know 10 students have a value of 0, we can determine that 12 students have a value of 1, and so on. Getting to the score of 5, we see that there are a total of 70 students who have a score of 5 or lower. Since 5 is the maximum value, we know that 70 is the total number of students in the class. Now let's calculate the IQR. And range. The range is equal to the maximum value minus the minimum value. Just looking at the score, we know that 5 is the maximum value, and the minimum value is 0. Thus, the range is equal to 5 minus 0, or 5. The IQR is the third quartile minus the first quartile. To find the first quartile, find the median of the first half of the data set. We know that there are 70 points in the data set, or 35 in the first half. The median of the first half will thus be the 18th data point, the middle point of 35. The 18th data point is equal to 1. We know this because 10 students have a score of 0 and 22 have a score of 1. A total of 22 have a score of 1 or 0, meaning that the 18th student must have a score of 1. So Q1 is equal to 1. Repeat this process to find Q3, the median for the second half of the data. There are 35 points in the second half of the data. The median of the second half of the data will be the 18th data point in the second half. This is the 53rd data point because there are 35 data points in the first half. The 53rd data point is equal to 4. We know this because a total of 51 students have a score of 3 or lower, and 61 students have a score of 4 or lower, meaning that the 53rd student must have a score of 4. Thus, Q3 is equal to 4. The IQR is the difference between Q3 and Q1. We know Q1 is equal to 1 and Q3 is equal to 4, so the IQR is 4 minus 1, or 3. Before we conclude this module, let's review. Remember that the range is the difference between the largest and smallest values in a data set. The positive sides of the range are that it's easy to calculate and it accounts for extreme values. On the con side, it's susceptible to outliers and does not account for middle values. The IQR is the difference between Q3, the third quartile, and Q1. The pros for the IQR are that it accounts for the center values of the data set, and it's not susceptible to outliers. The cons are that it doesn't account for extreme values, and it takes time to calculate. Notice how complementary the pros and cons of the range and the IQR are. They fill in gaps for each other. It's best when trying to analyze the variability of a data set to calculate both the range and the IQR. This will give you a sense of both the middle and the extreme values of a data set. This concludes our range and IQR module of elementary statistics. Welcome to the range and interquartile range module of elementary statistics.